That wraps up all of the viruses we will be discussing that are transmitted by Bemisia tabaci, the sweet potato whitefly. And we will now move on to the virus present in the United States that is transmitted by the greenhouse whitefly, Trialurodes vaporariorum. And for that one, we also have Dr. Wintermantel, who will be speaking on that one.
So this is a virus that I dealt with early in my career in California when we were having epidemic levels of greenhouse whitefly, and it was quite a concern for some of the local growers in my immediate area in the Salinas Valley. This virus is a little bit different than the other viruses I mentioned. It is transmitted exclusively by the greenhouse whitefly, not by the sweet potato whitefly. Everything else we've talked about today with whitefly-transmitted viruses have been transmitted by various sweet potato whitefly variants, usually either the B or Q biotype or MEM1 or MED. This one is transmitted only by the greenhouse whitefly. It's a whitefly that thrives in temperate climates and greenhouse production facilities. I will say that you can actually find sweet potato whitefly in greenhouse production facilities too, but this one is known particularly for its prevalence in greenhouses, largely since it was first characterized from greenhouses a long, long time ago. Beet Pseudoyellows virus, like other creniviruses, plants take a while for symptoms to develop. They begin with chlorotic spotting on young leaves near the crown, coalesce into areas of chlorotic mottle, become areas of interveinal yellowing with veins remaining green. This is very typical. One characteristic of Beet Pseudoyellows virus, particularly in greenhouse, you may notice this in particular, is in greenhouse production, the leaves become crunchy. While other creniviruses do this as well, Pseudoyellows in the greenhouse is characterized by that. You can actually crunch the leaf and you can feel kind of a crunchiness to it that you wouldn't feel otherwise. It's a little harder to tell that in the field just because of some of the way plants in the field will desiccate. The pattern of spread is the same as with other related viruses from the crown outward down vines. And when plants are infected young, they can become much more severely stunted, as is the case with this pumpkin plant that you see on the right here. Beet Pseudoyellows virus was the first whitefly transmitted yellowing virus identified by my colleague and predecessor, Jim Duffus, back in 1965 here in California. A number of other viruses have been given different names early on. Ultimately, they all were determined to be the same virus. Some of those include cucumber yellows virus, muskmelon yellows virus, cucumber chlorotic spot virus, and one called melon yellows virus, which differs from the melon yellowing associated virus in Brazil. That is a different virus. But the viruses here that we're talking about, these are all variants of Beet Pseudoyellows virus. Virus is found in many parts of the world where greenhouse whitefly populations exist, including Australia, Europe, and Japan, and again, temperate regions of the United States. Beet Pseudoyellows virus can be acquired by the greenhouse whitefly feeding on plants for as little as 1 hour, but efficient transmission requires longer acquisition and transmission feeding periods. The whiteflies can carry the virus for up to 6 days. Unlike watermelon chlorotic or stunt or squash leaf curl virus, the virus is lost actually much more quickly. There's a decline over time the longer the whitefly has been removed from the source plant. Just to look at the differences between the whitefly vectors here, you can see there's a structural difference between them. Greenhouse whiteflies are a little bit larger than sweet potato whiteflies. The greenhouse whitefly I like to describe as more of a fighter jet structure. The wings are a little more horizontal and you don't see a typical gap between the wings. Whereas with the sweet potato whitefly, you see a gap between the wings and the wings fold down more like the roof of a house. Nymphs of the greenhouse whitefly, not shown here, have long waxy filaments associated with them, whereas sweet potato whitefly nymphs do not have the waxy filaments. So these are ways you can actually look at the plant and see which whitefly you may have, and that can give you an indication, perhaps, if you have yellowing symptoms, which virus you might have, whether it be pseudoyellows or a different type of Bemisia-transmitted yellowing virus. Large populations of whiteflies, again, lead to rapid spread, either within a greenhouse or in a field. The warmer the temperature, the more the whiteflies will move, the more likely you'll have a greater infection in the field or the greenhouse. The virus, again, persists from season to season in infected cucurbit plants, volunteers, as well as weeds and other agricultural crops. Just to give some perspective on that, we did find a field in the Salinas Valley where we had a situation where whiteflies were moving out of an artichoke field, picking up virus in a strawberry field where Beet Pseudoyellows virus was present but not causing disease, and then moving into pumpkin fields and causing severe disease in that grower's pumpkin field. And so understanding the dynamics of that and managing that led to the ability to get the disease under control, and it's been well managed for several years now as a result. Pseudoyellows has an exceptionally broad host range, one of the largest host ranges of all viruses in the genus Crenivirus. Does, as I mentioned, infect strawberry and blackberry, two temperate type crops, sugar beet or table beet. It can go to lettuce, endive, spinach, and carrot with varying degrees of symptoms. Importantly, it produces an unusual symptom on some plants, such as this Beet Pseudoyellows virus-infected marigold, where you can see this reddening of the leaves in the upper right-hand corner. That is caused by the virus. Instead of an intervanal yellowing, you're actually seeing an intervanal reddening. That's also found on dandelion. Several yellowing viruses also cause similar symptoms on plants. This is an old photo taken by Jim Duffus many years ago. The virus looks very much like what you see with CYSDV or CCYV in particular, or even aphid-borne yellows. But can also, as I mentioned previously, look like begomoviruses, which can produce similar types of symptoms, even those that we don't have in the US. Molecular detection, again, is best for Beet Pseudoyellows virus. Like other creniviruses, some Antisera can cross-react. Again, I will not say Antisera, but Antisera are great. Don't get me wrong. I recommend Antisera, but there is some cross-reactivity, particularly for those made to creniviruses. So one cannot just assume that if you get a positive, it's that virus. Whereas molecular methods can be very specific and tell you which of the viruses you have. Again, I recommend RT-PCR, quantitative RT-PCR for measuring the amount of virus, and then high throughput sequencing can give you a full genome if you need it. Multiplex methods are available in many laboratories that allow you to determine which virus is causing your yellowing symptoms. Beet Pseudoyellows virus can rapidly establish if introduced into areas where reservoir hosts are. As I mentioned, this virus has a lot of hosts, so it's going to be hard to get away from it once it's there. Treat areas to remove those weeds. Also treat areas prior to plow down so that whiteflies don't move into new crops and weeds. Reduce the overwintering virus populations by eliminating those whiteflies before you take out your field. Reflective mulches, as I mentioned previously, are very effective, particularly in the field. Again, this is also a greenhouse situation, so that doesn't really address that. But in the field, reflective mulches can be very helpful to repel whiteflies and protect plants while they're young. Row covers could also be effective with this virus in areas where you are concerned about it. It's used less for Beet Pseudoyellows virus than for Babesia-transmitted viruses, but the methodology is appropriate for that as well, if it is economical for the producer. Transplants should always be monitored for whitefly-transmitted viruses. Look at transplants for whiteflies, eggs, and nymphs, both before and after transplanting. Monitor for virus titers, but be aware that, as with other creniviruses, many of these viruses will have very low levels when plants are young, and it may take about 3 weeks post-infection before symptoms develop, and up to a week and a half to 2 weeks before virus can be detected using quantitative PCR methods. So you may not be able to tell if the plant is infected. It's best to make sure that the facilities are well managed and whiteflies are under control in your transplant facility. and tried to raise transplants in areas where the transplanting will occur to reduce the likelihood of a virus being accidentally introduced into a new area. You can see here the symptoms on this. This is not Beet Pseudoyellows virus, but the principle is here. Young plants can develop symptoms. So look for those types of symptoms once you have the plants in the field. There is no known genetic resistance to Beet Pseudoyellows virus at present in cucurbit crops. This is a virus that is not seen as frequently as it was in the past, largely because of the abundance of Bemisia displacing it and better management, I believe, in some of the coastal or greenhouse production facilities. But this is still a virus of concern in many parts of the world, and it is one we should pay attention to, and it does look much like the others. So that's pretty much all I have on this virus. It is the only greenhouse whitefly transmitted virus that we're talking about today. And hopefully at some point we'll have a fact sheet on it. We don't have one on this one yet. Thank you.
All right. Thank you so much, Dr. Wintermantel.